Now we'll be looking at question number 26, and we can start off by reading it real quickly. Suzette is studying the growth of bacteria in a petri dish. She grows 100 colonies of bacteria in dishes with varying pH levels and at varying temperatures to find the optimal conditions for bacteria growth. The pH level and the temperature of the 10 colonies with the most rapid growth are used to determine the optimal ranges, and the results are shown in the graph above. Based on Suzette's graph, solving which of the following systems of equalities yields the optimal pH, x, and the optimal temperature, y, for bacteria growth. Now, this is a really trick question in the sense that you don't need a majority of what was just said to you. I'm not a science major. You don't need to know, how pH levels work or anything like that. You don't even need to know what the x and y value stands for. You just need to focus on two words: optimal range. They want to see which of these equations or system of equations best fits the optimal ranges shown in the graph. Now, to save on time, I'm just going to show you that the answer is A, and explain why answer B does not work. So let's look at answer A. They have an equation for x, which is x minus 7.3 is less than or equal to 0.1. So let's try plugging in the two maximum values. So we have 7.4 minus 7.3 is equal to 0.1, which is less than or equal to 0.1. So that works. And 7.2 minus 7.3 is equal to negative 0.1, which is equal to 0.1, which is less than or equal to 0.1. And so it works. And so we see that x function is fine. Now we can look at the y one. The x equation is fine, and we can look at the y one. So we have a maximum of 37 minus 33.5, which is equal to 3.5, which is less than or equal to 3.5. So that works. And we can look at the min, which is 30. So we have 30 minus 33.5 is equal to the absolute value of negative 3.5, which is just 3.5, which is less than or equal to 3.5. And so the y1 works. And so you see that this equation perfectly maps the optimal ranges for both the x and y values. Now, the thing to note is that the other answers also seem correct. So for example, we can look at answer B and look at their x equation. So their x equation is x minus 7.2 is less than or equal to 0.2. And so we can plug in the maximum. So we have 7.4 minus 7.2 is equal to 0.2, which is less than or equal to 0.2. And so that works. 7.2, and now we can plug in the minimum. So which is 7.2 minus 7.2 is equal to 0, which is less than or equal to 0.2. And so we see that this equation does include the optimal range. The main problem is that it includes more than that. That isn't covered by the optimal range. So, for example, if we go even lower than 7.2, which the graph says is within the optimal range, and go out of it and go to 7.0, we see that 7.0 minus 7.2 is equal to negative 0.2, which is equal to 0.2, which is less than or equal to 0.2. And so 7.0, which shouldn't work because it's not in the optimal range, does in fact work, which means that B must be false. This can be seen in also C and D, where either the x or y value have much more than just the optimal range. A is the only equation that includes just the optimal range.